Hi everybody, I am Dr. A. Rizwana, working as Assistant Professor in the Department of Mathematics, VHNSN College, Autonomous, Virudhunagar. In this video, I am going to present the basics and applications of graph theory with special reference to chemical graph theory. To start with, let us see what is mathematics. Mathematics is not about numbers, equations, computations or algorithms. It is about understanding, says William Paul Thurston. Yes, mathematics is not a language of number. It is just understanding numbers. Yeah, it is a powerful tool. Mathematics is the most beautiful and powerful creation of the human spirit, says Stephen Banach. Trick. Let me give you a beautiful trick to learn mathematics. Think, work, achieve and develop. Think on the mathematical concepts. Work hardly on the mathematical concept. Achieve your mathematical concepts and develop your mathematical concept. And this forms a trick in learning mathematics. Let me give the basic definitions of graph. A graph is a collection of dots, vertices, lines or edges that join the points. In this figure, there are 3 vertices and there are 4 edges. And this is a graph with the vertex set V and the edge set E. In this figure, it has 6 vertices and 10 edges. Let us see what is the concept of loop, isolated points and multiple edges. Loops are points which start from a particular vertex and ends in the same vertex. Isolated points do not have any edges incident on it. In this figure, the point C is an isolated point. Multiple edges. Multiple edges are formed when there are more than one edge joining 2 vertices. Here the vertex A and B are joined by multiple edges. The degree of a vertex. The degree of a vertex is the number of edges incident on it. In the example of the graph given here, we have 5 vertices A, B, C, D, E. The vertex A has 4 edges incident on it and it is even. The vertex B has 4 edges incident on it and the degree is even. The vertex C has 3 edges incident on it and hence it is an odd. The vertex D has 3 edges and similarly the vertex E has 2 edges, etc. Now let us see the varying applications of graph theory. Graph theory is used in computer networks, medical analysis, solve short problems between cities, scheduling exams, sports scheduling, mobile towering and traffic signals. Let us see the graph models, some examples of graph models. A network which consists of cities and flights can be compared with the graph. Cities represents the vertices and flight represents the edges. Similarly, a network with people and a pair of friends represents a graph model. Authors and co-authorship represents a graph model. Telephones and phone calls represent a graph model. Web pages and linkings represent a graph model. Genes and regulatory aspects represent a graph model. Let us see some examples of graph, and these are example of geometric graph, algebraic graphs, and here is a picture of a real graph. Here is an example of a social media graph. The first graph is a complete graph where all the 7 friends are friends to each other. And this example 2, we can see Dave and Tony are friends, whereas Dave and Jeff are not friends. Graph theory in electrical networks. An electrical network can be represented in graph theory, and here depicts a picture of how an electrical network can be represented as a directed graph. Tripartite network in medicine. In medicine, the concept of abdominal pain associated with its symptoms and the persons having those symptoms can represent a tripartite graph in graph theory. This is one set with the abdominal pain, and this is the set of symptoms, and this is a set of persons, and this network represents a tripartite network. Graph coloring in games. Graph coloring is an important concept in graph theory. This concept can be used to solve puzzles like Sudoku. Here a 4x4 problem is solved using the graph coloring. So we can conquer the crazy cubes using graph theory. Here are some crazy cubes, and these crazy cubes are converted to graphs, and each color represents each vertex, and corresponding vertex U and V are paired to each other if the opposite face colors are paired. For example, here green and red are in opposite to each other, so a edge lies between green and red. Here blue and white are in opposite colors, so there is an edge between blue and white. Similarly, green and white are in opposite colors, so there is an edge between green and white. Using this constructive model, we construct a multi-graph containing all the 4 cubes. Graphs in food chain. Zoology people can use the graph models to explain the food chain happening in the ecology. This is an example of a disease contact graph given by Jim Walker in 2008. And let us start with the important section here, mathematical chemistry. Mathematical chemistry is engaged in novel applications of mathematics to chemistry. Major areas of research in mathematical chemistry include chemical graph theory. Chemical graph theory is a branch of mathematical chemistry which applies graph theory to study molecular structures. See how graphs are constructed in chemistry. This is a propane molecule, and the propane molecule is converted to a graph P3 here. Carbon atom represents the vertex, bonds represents the edges. Here the degree of the vertex is nothing but the valence of the atom. So using this concept, topological indices is an interesting area in chemical graph theory. And before going to topological indices, I'll just give what is a molecular graph. A molecular graph or chemical graph is a representation of the structural formula of a chemical compound in terms of graph theory. Here the structural formula is propane, and it has been expressed in terms of graph theory. In chemical graph theory, vertices corresponds to the atoms and the edges corresponds to the covalent bonds. A hydrogen depleted molecular graph or hydrogen suppressed molecular graph is the molecular graph with hydrogen atoms deleted. Topological indices is an interesting area in chemical graph theory. It is a developing area of research. This concept is widely used by the chemistry researchers to understand the physical and chemical properties of compounds. Today, various chemical compounds are being introduced in the field of chemistry. It is important to study its physical and chemical properties. So, topological indices is a concept which can be used to study the physical and chemical properties of a compound. The characterization of a molecule by an associated graph leads to a large number of powerful and useful discriminators called topological indices. The topological index is nothing but a numerical representation of the entire graph. The topological indices are widely used for the studying the psychochemical properties of chemical compounds. See here we can see the equivalence between the chemical and mathematical terms existing in chemistry. An atom represents a vertex. A molecule represents the molecular graph. A covalent bond represents an edge. A cyclic hydrocarbon represents a tree in graph theory. Alternate structure represents the bipartite graph. Valency represents the vertex degree as such. In chemistry, hydrocarbon is an organic compound consisting entirely of hydrogen and carbon atoms. Hydrocarbons with linear structure is called acyclic hydrocarbon, and with ring structure is called cyclic. Here is an example of an acyclic hydrocarbon, alkanes. And this is a picture of ethane molecule, and this is a picture of propane molecule. It has been converted to a graph structure called path P2 and path P3 respectively. Acyclic hydrocarbons, unsaturated hydrocarbons are with those with double bonds and triple bonds. Those with double bonds are called alkenes and those with triple bond are called alkynes. Here is an example of alkenes and alkynes. This is an ethene molecule with 2 carbon atoms. This is a propene molecule with 3 carbon atoms. Ethine and propine with 3 double bonds. And ethane with 2 carbon atoms and propine with 3 carbon atoms. The graph representing the ethene and propene are multigraphs. And ethine and propane are also multigraphs. Now we can see the concept of neighbors and non-neighbors with an example of a graph here. Take an example of a graph V1, V2, V3, V4 and V5. The vertex V1 is adjacent to 3 vertices, that is V2, V3, V5. It is not adjacent to V4. So the number of non-neighbors of V1 is 1. The number of neighbors of V1 is 3, that is V2, V3 and V5 respectively. But if we take V5, V5 is adjacent to V4 and V1. So the neighbors are just 2. The non-neighbors are V3 and V2. Hence the number of non-neighbors is 2. Using the concept of neighbors and non-neighbors, we can see some topological indices. One example of topological index is harmonic index, where harmonic index is equal to summation of 2 by the degree of u plus degree of v. For each of the edges, we calculate this formula and we find out a number. Similarly, by using the non-neighbor degree, we use this formula of topological index, non-neighbor harmonic index, where it gives the summation of 2 by d of u bar plus d of v bar. Non-neighbor harmonic index has many applications in chemistry. One is, by using this formula, we have computed the values of the alkanes shown before, and it represents most of the boiling point of the alkanes, and these are the N-pentane, N-hexane, N-heptane molecules, and the boiling point of alkanes are 36, 69, 98 respectively. Using the formula, previous formula, we have computed the value of non-neighbor harmonic index to be 1.8, 1.57, 1.44, etc. And we have computed the boiling points to be 36, 69.08, 97.92. It approximately matches the boiling point of alkanes. Without having the molecules, just by calculation, mathematical calculation, we can compute the boiling point of alkanes. This is a major application of this topological index. In such a way, we can use the topological indices to find the boiling points or the physical and the chemical properties of various chemical compounds in chemistry. Thank you.